Hi students, in this class we will discuss few questions from the topic electricity. We have already learned the heating effect of electric current in the part 6 video. First question, calculate the quantity of heat produced in a 20 ohm resistor carrying 2.5 ampere current in 5 minutes. From the question, it is clear that we need to find out the quantity of heat produced. H is asked in the question. In a 20 ohm resistor, resistance value is given as 20 ohms, carrying 2.5 ampere current. I value is 2.5 ampere. In 5 minutes, time is given in 5 minutes. It is given as 5 minutes. We know 1 minute is equal to 60 seconds. Therefore, 5 minutes will be 5 into 60 seconds. You need to convert time into seconds because we know the SI unit for time is seconds. What is the expression for heat? The quantity of heat H is equal to I squared RT. We have the values for I, R and T. Substitute these values, you will get the answer. What will be the unit for this heat energy? Heat is a form of energy. The unit will be Joule. The answer is 37500 Joule. Second question, how does the heat produced in a wire or a conductor depend upon A part, current passing through the conductor, B part, resistance of the conductor. We know the expression for heat as H is equal to I squared RT. From this expression, you can easily answer this question. The heat produced in a conductor is directly proportional to the square of the current, and it is also directly proportional to the resistance of the conductor. Heat produced in a wire is directly proportional to the square of the current flowing through the conductor. Heat produced in a wire is directly proportional to the resistance of the conductor. Question number 3. State Joule's law of heating. We know when an electric current is passed through a conductor, heat is produced after some time, and this is known as heating effect of electric current. Joule's law of heating is a mathematical description. H is equal to I squared RT. It is the rate at which the resistance in a circuit converts electric energy into heat energy. An English physicist, James Prescott Joule, discovered this Joule's law. It is named after this scientist who discovered this. According to this law, the amount of heat produced in a conductor is directly proportional to the square of the electric current passing through the conductor. The amount of heat is also directly proportional to the resistance of the conductor. Also, it is directly proportional to the time for which the electric current passes through the conductor. To state Joule's law of heating, please remember this expression H is equal to I squared RT. Question number 4. A current of 2 ampere passes through a conductor and produces 90 joule of heat in 15 seconds. Find the resistance of the conductor. Current I is given as 2 ampere and H is given as 90 joule. Time is equal to 15 seconds. We need to find out the resistance R. We know the expression H is equal to I squared RT. From this, R is equal to H divided by I squared T. Substitute the values. H is equal to 90, I is equal to 2. Therefore, 2 squared is 4. into T is equal to 15. R is equal to H by I square T. It is 1.5 ohms. The unit for resistance is ohm. Question number 5. Write an expression for the electrical energy spent in flow of current through an electrical appliance in terms of current, resistance and time. What will be the answer? I squared RT. In terms of current, resistance and time, this is the electrical energy spent in flow of current. Next question. Why does the core of an electric heater not glow while the heating element does? The heating element of an electric heater is made up of alloys. Please remember, this heating element is made up of alloys, and these alloys have very high resistance. So when the current passes through the alloy, it blocks the current and doesn't let it pass through it. Thus the heating element becomes hot and glows red. On the other hand, the cords are made of good conductors like copper. Good conductors means they have very low resistance and they do not produce much heat when same amount of current is passed through it. Hence the cord doesn't glow. Question number 7. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. You have to compute the heat generated. That means H is asked in the question. While transferring 96,000 coulomb of charge. This is the charge Q. Q is given as 96,000 coulomb in 1 hour. 1 hour means time is given as 1 hour. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. Therefore, 60 minutes is equal to 60 into 60 seconds, 3600 seconds. Potential difference is 50 volt. V is given as 50 volt. The expression what we know is H is equal to I squared RT. This expression can be written as I into RT. And we know V is equal to IR. Therefore, replace this IR by V. I into V into T. Or you can write H is equal to VIT. H is equal to VIT. V is equal to 50 and I you need to find out. T is given as 3600 seconds. How will you find out I? We know I, electric current I is Q by T. Find out I from this. 96,000 divided by 3600. When you do this, you will get the value of current I. Charge transferred Q is equal to 96,000. Time taken 1 hour is equal to 3600 seconds. Potential difference V is equal to 50 volt. H is equal to VIT. This, when you substitute H, you will get as 50 into 80 by 3. I value is 80 by 3 ampere into 3600 seconds. The answer is 4.8 into 10 raised to 6 joule. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.